Hey guys, welcome back. So in this video we're gonna discuss about Spring. So a Spring is nothing but it is a Java's framework. So it is one of the most used framework in the industry, which is related to Java. So let's see why something like a framework like Spring was needed for this Java community. So firstly let's try to understand the difference between a library and a framework. So as of now, we have seen a lot of libraries in Java. So namely, we have seen the threads, we have seen math library, we have seen some other libraries which are only used for utility purpose because we don't develop something big with them. So we only try to make our job easy by letting those libraries do a lot of stuff for us. So usually any component of Java will be made in terms of two aspects. You either write the logic or you import the logic. So if you're writing the logic, it is mostly it is very much dependent on your business requirements. So it is very specific. So you write your own logic, but there will be some sort of utilities or some sort of functionalities which are very much common. As for example, that when we need to use some of the mathematical library, mathematical operations like the square root, the minimum, or maybe if we want to do some sort of operations like search and all these things. So all these sort of algorithms are very much common in every application. So instead of you writing it every time, so Java is going to provide you with a library which will have all of these functionalities implemented. So you can just use them. So it is what the actual purpose of a library is. But a framework is a bit different. A framework is also similar to a library. It's going to provide you a lot of functionalities, but on top of it, it is going to give you a lot of a pre-built work which needs to be done if you were to build something big. If you want to build an application, so you need a lot of things to be working. You need some sort of servers, you need some sort of mechanisms, you need some sort of configurations to be done. So you need some framework to be already implemented, so that you just have to put your own logic into that, so that it becomes a full-fledged application. So all these common functionalities of full-fledged applications, if they are provided to you through some sort of library, we can call it as a framework. So a framework is nothing but a library of some external tools which are highly customizable. They have to be very much customizable. If it is a very opinionated thing, then then the, then it is not a much of use, because you want to tweak some of the operations which are there. So you want to implement your own way of working, right? So that's how these two things differ. So let's see. So as we discussed, Spring is one of the framework. So Spring framework of Java is actually a framework that can do almost anything that you need in Java. It's so you can you so it is mainly used for enterprise application development, but we can use it for web applications. We can make some sort of security configurations. We can do a lot of things in the Spring. So a Spring is not just a simple framework. It actually comes with a lot of modules. Each of them are going to work for a specific aspect. So one of the most important aspect that this Spring offers is something called as the dependency management. So what is a dependency? So here, let us say we have two classes here. So this is a class A and this is the class B. So in this class A, so this class A needs something from the class B. So it needs the class B's object to do some operation. So let's say this is your main program, and this is some sort of a student object. So in your main function, you want to create an object of the student, and you want to supply some values to that object. So that means that class A is dependent on this class B. So it's a dependency. So that's a very uh, basic way of understanding how a one class is dependent on other class. So so it seems to be not a big problem because we can we can always import classes from anywhere, and we can instantiate them, and we can do whatever on the class if it is provided us with those defaults, right? But it's actually an issue when you're trying to implement some a very big service. So let's say this is a service, and it has a few clients. So while creating such an application, here we're trying to see in in this case these client objects are very much are they are implemented with respect to the service implementations. Uh, it means that whatever the service class that we have written, it has this entire code of this client. So that means if we were to if we were to modify anything regarding the client, so we have to change a lot of things in this service implementation class. If we Okay, for example, if we don't want that client to be uh, part of the application, then to actually remove them, it requires a lot of work to be done, because they are so much tightly coupled in the way they are created. So if we were to so as an example, let us say in the main function you want to create an object of student, but in the future you wanted to create another object of employee. But no, it's not so easy, because you have in your main function you have created an object of student, then you have used all the setters and getters, and you did a lot of stuff regarding the student. So you have to change all of that into the employee employee implemented functions and functionalities. So it is going to be a bit difficult, right? For this we use some pattern, which is the injection pattern. Instead of directly implementing the student, or directly implementing the employee, so we're going to use some sort of interface which is going to you know uh, which will be internally implemented by all of its subclasses, like the student and employee. So let us say we have some sort of uh, interface called as a customer. So in this customer interface, we are going to define some method, like a fill values. So that fill values will actually this customer interface object will be created in the main, and whenever you need an object of student, you can you can pass the reference of the students as it is implementing, and whenever you need the an object of the employee, you can create and pass the employee. So here we have achieved something called as a loose coupling, because whatever the clients, whatever the dependent objects that we have, so they are not fully dependent. They are they're only dependent via a injector, and injector was supposed to be the injector, as it is a super interface, it is going to work the same. So we don't have to change a lot of code for that. So this is the architecture that a Spring wanted. So a Spring tried to create it something very similar. It uses something called as an IOC framework. So we needed something called as an IOC framework. As a Spring is not in the is not in the picture yet. So in the translation, the main function is going to call all these dependent objects. So it's not a great idea, because we might have multiple injector classes. So managing all this is not an easy task. So we are going to use something called as IOC framework. Why are we calling it as IOC? So here we can see that the main program is actually holding the control of all these objects, but here all the creation and the life cycle of these objects will be managed by something called as an IOC container, or IOC framework. And then this IOC framework will be used by the main function. So we're only interacting with the IOC container, and IOC container is internally managing all the creation and destroying of all these objects. So then, okay, what's the need for Spring? Okay, so the needs for Spring. So the Spring was needed because the JW technologies like JSP servlets and EJB are very complex to build. We have to write a lot of lines of code, so they're not very configurable, right? And also they are heavyweight. So by heavyweight we mean that All these classes are extending a lot of interfaces above them, and there are a lot of dependencies. So while they are executing in the memory, so they are going to occupy a lot of memory, so they become very heavyweight, and they are not manageable because all of this control will be a manager. We need to manage some part, and some other part will be managed by the solid container or all these things. So there is no fixed control over an object. So they're not so much manageable. Right, so this is the basic MVC architecture that we have seen. That so for the controllers we use Servlet, for view we use JSP, and for model we use the Java beans. Actually, this was the main problem actually existed when we have to deal with the Java beans, because Java beans are implemented using some technology called as EJB. EJB is nothing but an enterprise Java bean. So EJB container is going to maintain all the enterprise beans which are going to interact with the database. But EJBs are very heavyweight. You are supposed to write at least 100 lines of code to actually make them work. So they become a very heavyweight. So a Spring wanted to use something lightweight instead of an enterprise bean. So instead of an enterprise bean, so they started using something called as Pojo. It's nothing but a plain old Java object without any specific uh, uh, pre-configurations which are needed, and to manage that, a Spring has its own mechanism to manage something as simple as Polus. So how is it going to be managed? So it's going to manage using the IOC container. So now let's see what IOC container is going to do. So we are going to define all our objects, all these business objects. So we call them as polus, and these will be given to the Spring IOC container. Okay, then the Spring IOC container will not know, what object to be instantiated when. So uh, we have to provide the configuration on how those objects were to be created, how they were to be executed, and if they were to be injected, how are they supposed to be injected into this. So all of this will be given in the configuration metadata. It can be written in many forms. You can either use XML based or Java based or annotation based. So using all this configuration data, Spring IOC container is going to prepare the applications with all the dependency management, with all the injection of this object. So everything will be done, and finally we will have a fully configured application which is ready for deployment. So this is what the Spring offers us. So dependency injection. So this is what so this is how the IOC container internally manages them. So IOC container will read the XML or Java configuration file. It is going to create the a dependent bean, and it is going to push it into the a bean which is which needs the injection of this bean too, right? So IOC container is going to create uh, both the beans, but it is going to inject them, and finally it is going to give you the it is going to give you all the uh, components which are fully functional now. So this is the process in which the bean is initialized. So we are going to define the bean, and the post processing instantiation setter, and bean is ready for use. So at the end, so you're going to get a class which is bean, which has all the dependencies managed. And IOC container, Spring offers two ways of creating the IOC container. We can either use the a bean factory, which is the older way, and now we're using something called as application context. Anyway, both of these objects are nothing but the IOC containers. Right? Let's see what the Spring framework actually is. So this is what the a Spring framework comes up with. So it has a lot of components, but the main component is the Spring core. So the Spring core is the component that enables the dependency injection. And then we have something called Spring AOP, which is the aspect oriented programming. We're gonna see what aspect oriented programming is. And then we have ORM, which is the object relation mapping, and the Spring DAO. So these two components are related to the data. And then we have the Spring Web and the Spring Context. These are used for developing the web applications. And then the Spring Web MVC. So it is going to implement the MVC architecture. and it can be used to create a web MVC applications. And so this is the runtime. So this is just an extension of it. How they internally have some other components which work together. And so this is the core container which will have the Spring core, the context, the beans, and the Spring expression language. And then we'll see what this aspect oriented programming is. As we defined aspect, EOP, and aspects, instrumentation, all of these things are are somewhat new to us because we haven't used this in Java. In Java, we use something called as object-oriented programming, but there is actually an issue with object-oriented programming. So what is the issue? So what if every object needs to have some sort of common functionalities? So we either define them in a interface, and then we try to inject that into the code. But instead of doing that, so if so let us say that logging a security and the transactions, so all these aspects are needed in every class of Java, or in most of the class of Java. Then for such a case, we can separate the logic. So we can separate the aspect concerns, and we can create this logging, security, and a transaction as different aspects inside the program. And whenever they're needed, we can just cross-cut and place it in the program. So this is what the aspect oriented program is going to provide us with. And then the Spring Web MVC. So this, so as we've seen, the Spring, the a Spring a Web MVC is going to use all the JWT technologies, but it is going to have some sort of a predefined structure which it is going to follow. It is going to have something called as a dispatcher servlet, which is going to take all the requests, and it is also responsible for providing the response at the end. And then initially it is going to use the handler mapping to actually see which servlet needs to be called for this specific request. And then and then it will be given to the controller, which has all the actual servlets which are going to execute. And then the servlet is going to execute, and as a result it might provide you with a model or a view, and the model or view is going to be given to the view resolver, and the view resolver is going to map the exact view that needs to be presented to the user. And after getting the info, it is going to fetch the view, and it is going to give it as a response. So this is how the Spring Web MVC work. So this is all about Spring in a very high level. So we'll see you in another video.